Welcome to my channel, exploring old technologies and seeding new ideas. Let's begin.
Typically, ham radio hobbyists, hams, don't like to spend money on anything they are not sure they'll like. Therefore, my goal was to avoid spending hundreds of dollars on a brand name Iambic Paddle Style Key before I was sure I'd even like using Morse On-Air. Especially since I liked using voice and digital modes that I was already familiar with. If you have 3D printing as a hobby, or a friend with that resource, this video is for you. What is the risk here anyway, I wondered? After all, a Morse key is just a simple set of switches, which any modern transceiver can likely clean up any contact noise from. A quick search online for 3D printed Morse keys will point you in the direction of lots of relevant 3D printable download files, and most of these are free from those who have already made Morse keys for themselves. However, with access to a computer-aided application, CAD, something also available free online, I chose to sketch out what I thought might allow for customization. This brought a third hobby passion to bear. In my case, providing an opportunity to experiment with various approaches for my Morse key. Assuming success, a main advantage of this approach is an endless source of replacement parts. The images you have been watching came from my CAD work as I experimented with various ideas. Originally, I was going for a spring-loaded return between the paddles. The next images are from the 6-hour 3D printing process to create this approach. At the end, I was presented with the PLA parts to assemble and test. These parts consumed 36 grams of material from the 500-gram filament roll. Finally, version 1 is ready to assemble, wire up, and try. So sadly, the paddle action did not feel quite right when used, so I needed something better than a simple spring. Using opposing magnets seemed a potential alternative worth trying, so I taped some to the paddles. This proved a positive improvement worthy of redesigning in, resulting in new parts being 3D printed. An assortment of bolts, nuts, washers, and wire terminators were engaged, resulting in version 2's assembly. Here you see the very simple contacts created from carefully spaced bolt ends. Finally, we have the wired assembly with the new addition. A connector has been added to eliminate the previous wired-in cable approach. The paddle feel of the newly assembled parts was greatly improved, but the unit needed more weight to keep from moving around while used. My quick solution was to use an old washing machine tub wrench, which cost more than the rest of the Morse key. I put an old speaker magnet in the center to mate with magnets that I embedded in a separate 3D printed mount. I designed mounting holes for each part to secure them together. As an alternative to the weight, one could screw the key to a plate that would be then screwed to a table. Snapped together for testing, it worked great during a local club show and tell night. Hopefully I've been able to demonstrate the value of 3D printing to make your own gear and avoid some of the higher entry costs of the ham hobby. Worth noting in this case is that a multi-use 3D printer can approach the cost of many brand name Morse paddles.
I hope you enjoyed the video, and I'll be looking forward to preparing another one for you soon.